Okay, so a student, in addition to preparing the buffer solution, a student submitted this problem that the Syngaze asked. Okay, so it's saying the protonated tertiary amine form is like this with this protonated nitrogen, and this is the Heps H because we've got a hydrogen on here. And the unprotonated form is going to be the Heps -1, which means it's missing this hydrogen, and it's also missing this hydrogen over here, so that's the -1 form. So we've got the Heps H and the Heps -1. So this is actually our HA that we talked about in the previous video in our buffer solution with a pKa of 7.55, and this is our this pKa of this hydrogen here, and this is our A minus. Okay, so we can use the Henderson-Hasselbalch equation to calculate these questions. So calculate the concentration of Heps H in the buffer solution and calculate the Heps -1 in the buffer solution. Oh, first we got to calculate the ratio of the concentrations of Heps -1 and Heps H. Okay, so we actually did that earlier. So we saw that the pH is equal to the pKa plus the log of A minus over HA. Okay, so A minus over HA is equal to 10 to the pH minus pKa is equal to 10 to the 7.8 minus 7.55, I'm sorry, which is equal to 1.78. Okay, so that's our A minus to HA ratio. So that's the first part of this question. The second part says calculate the concentration of Heps H in the final buffer solution. Calculate, and we did that. We did that earlier because you'll remember if you go back to the original video, I'm sorry, we did the calculation of the -1 of our A. So remember, the Heps H is our HA, and the Heps -1 is the A minus. So if you go back to the previous video for the problem 13, you'll see that we calculated our A minus to be equal to 0.016 molar, okay? And we calculated that from using the set of equations, the set of two equations. So we calculated that in the previous video. So now we need to calculate our HA, and we can do that from the Henderson-Hasselbalch equation. So we see that pH is equal to the pKa plus the log of A minus over HA, which is, so the pH is 7.8 is equal to 7.55 plus the log, and we calculated the 0.016 in the last video over HA. So to get rid of that HA, sorry guys, I'll finish this in just a second. So to get rid of that, we got to raise everything 10 to the whatever, and so we got 10 to the 7.8 minus 7.55 plus equals, sorry, equals the log of got distracted by the phone, is equal to 0.016 over HA. Okay, so then we can say that HA is equal to 0.016 over 1.78, and so I'll let you guys calculate that on your calculator. So we've calculated the concentration of HA. We did A minus in the last video, and that's what we used to, add to our 0.025 moles of sodium hydroxide, remember. And then we got our A minus over HA ratio. Okay,